First Spin. Welcome to First Spin, a show where I learn about the parallax propeller without, I was going to say any, but with little prior programming experience. And rather than do this on my own, I have enlisted the help of two experts.
Now, you didn't have any prior programming experience before we started the show, but obviously,
I suppose,
as soon as we got a few episodes in, you've had experience now.
Right.
Yeah.
Yeah. When I run my code the first time now, it works for the most part.
Well, sometimes it works.
Yes. Huzzah!
She wrote a program last night when she was working on stuff, and she wrote it all and then loaded it into the RAM, and it just did what it was supposed to.
I know.
First time.
It was amazing. It was a miracle. It was a revelation of awesome proportions.
I don't know if I would call it a miracle.
It was a miracle.
It's not a miracle because we have been teaching you and you are getting better. And so it's not a miracle. It's just you're advancing in your knowledge and abilities.
You'd think so, but then shortly thereafter, she did something else.
Shut up.
Well, that was a more mechanical epic failure than a coding epic failure.
So there's like 5 of us that were trying to help Addie fix this bug in her code last night for an hour,
I was
2
messing
hours,
around.
something like that.
I was working on altimeter code, and I think we've gone through that already on the show, but I was working through altimeter code, and I ran the code and was like, what the heck? Why are my values all messed up? My altitude was like negative 6,000 feet and 2,000 meters, and my pressure was such that I probably should have had like my brain squashed, and no matter what I tried, like I must have tried, I tried the demo code from learn.parallax.com. I tried my own code that I cited on my Tumblr post.
She even had me download a copy of her code and run it on my altimeter, and mine worked perfectly.
Yep.
She double checked the wiring connecting the module to the microcontroller.
Yeah, I changed where the wiring was going to, and then we were streaming at this time, so we're looking at it, and then Roy's like, "Hey, where's the white chip?" I'm like, "What do you mean, what white chip? What white chip?"
The altimeter has a little white chip. The actual altimeter chip that senses the pressure and all that is a little white IC package.
Yeah.
So sometimes we're live streaming from the studio when we're working on projects.
Yeah.
So Roy was able to see this through our camera, but there was no white chip on the module.
Yeah. And I looked at it, I'm like, well, it says 3-axis on it, and there's no such thing as a 3-axis. I mean, I'm sure, but there's really...
a
3-axis altimeter doesn't really make sense.
So she had a gyroscope plugged in.
I had a gyroscope plugged. I was like, wait a minute.
Well,
my gosh.
Luckily for you, the pinout is the same between those two modules from Parallax, so you didn't accidentally fry anything.
I know. And the thing is, okay, so I am not the first person to make this mistake, because I was helping someone on the forums, and they also had like negative 6,088 feet and negative 20 whatever 2,000 meters of like weird altimeter issues, and our code was like exactly the same, and I said it was working, and he said no, it's not working. And I think it's because he might have put the wrong module in.
Yeah, it's probably true.
I think that's what it is, because
I mean they both are I2C devices, but they have different addresses, so your altimeter code would just be ignored by the gyro, so you would probably just get zeros back or no values back.
Right.
And that's why it would just mathematically calculate some arbitrarily large negative value.
Right. But it wasn't that arbitrary, because no matter what I did, it came back with the same
bad value. When I say arbitrary, I mean it's just the math causes it to be that particular value from zeros for the readings.
Yeah, you're feeding it zeros, and whenever you feed it zeros, no matter how you feed it zeros, how many times you change the code, it's still going to be getting zeros as its inputs.
Yeah.
From the actual chip.
So, yeah, we spent like half an hour on that stinking problem. And I was like, why? I don't understand it. My code was working beautifully. I don't get it. And then Roy had to just be like, hey, no white chip. What? Wrong module? What? That was embarrassing to say the least. But now I have shared said embarrassing story to you guys, so you too can laugh at me.
I have to admit, in the distant past, I have done similar incorrect module things.
Yeah. Is this an admission? Are we doing a truth or dare on first
it's
spin?
an admission in the distant past when I was more of a noob.
I see.
I've never done anything like that.
Oh, please.
Oh, I don't believe you at all.
Please. I don't believe that either.
Have you tried turning it off and on again?
The pat answer for fixing any computer problem.
Yeah. I told Addie that she should check the data that was actually coming out of the module that she was talking to, and she proceeded to ignore me. And if she hadn't ignored me,
but I wouldn't
then
have
she would have very
known how to,
quickly noticed that the string coming over that bus was
how do you
not
tap into that?
Not elevation.
You would just read the raw values instead of letting the altimeter driver do the processing to turn it into an altitude.
So that needs to be an exercise for you in the near future. When you're talking to these modules over I squared C, what is it?
Yeah.
I2C, I squared C.
Same thing.
So you need to write yourself a little, think of it as a little viewer program that just translates it from that over to your Parallax serial terminal.
Right.
So you can just see the data as it's coming in from the module.
Yeah, some of the demo code from Parallax will literally just be that. It'll just be dumping out the raw values. But oftentimes the demo code will do something a little more, like the altimeter code does quite a bit of math and calculations on it to give you the various values.
Right.
So this is good advice for everybody, really. If you do something that smart, we'll just call it smart because it's on a smart scale. I'm not going to say which side of the scale it's on. I think we all know. But the best thing to do is share it with like 1,000 people, like Addie's doing right now.
And then you'll never do it again.
Yeah. You might help somebody else who would potentially run into the problem.
Well, it's true because, like I said, in the forums, there was someone who got those exact values, and I was able to say, like, hey, I'm an idiot. Oh, you might want to make sure it's the right module. He's like, yeah, I don't need it anymore. Thanks anyway.
Yeah.
Oh, well. So anyway, so that's my story of the week. But this week we actually have a new module that we wanted to talk about really quickly because it's actually pretty easy. It's called the Polar Heart Rate Receiver. Right. And it receives heartbeat signals from a compatible sensor transmitter. And in my hand, it's a Polar T34 transmitter. I believe it's sold separately from Parallax.
Right. There are other Polar brand transmitters that are compatible that some people might have also.
And it has like this, I don't know, thick plasticky thingy, and then it's got like a waistband around it, and the two electrodes are...
It's like a really nerdy belt.
Yeah.
Except that it goes up around where your heart is at instead of down around your waist.
Right. Well, you're getting older, Roy, so... Like a really nerdy belt.
It needs to read your heart. It has to be over your heart.
Get your pants up there, bud. You know, right under the nipples.
Up that
high. So it's yeah, you got to put it up pretty high near your heart, and there are these two little tiny electrodes that are they look like they're part of the plastic. Really, if I didn't know they were electrodes, I probably would have just snapped them off. But I didn't. And yeah, I know. So that's the transmitter part. You put that on your chest or you strap it to yourself. The receiver itself, which is also again from Parallax, is about 3/4 of an inch by 1/2 inch. And it has well, it doesn't come with a header, so you need a 3-pin header. And I was actually a little surprised because usually Parallax puts their headers onto their module boards.
Right.
So
I
when
think
she
it's
was setting
because-
it up, she handed it over to me and she was like, "Can I steal some of your headers?" And I was like, "What do you need my headers for?" And she showed me, and the board didn't have a header on it, but thankfully I had some of Jason Todick, Todick.com sent me over some header strips that actually have round pins on them. So they slide in and out of breadboards. Super, super great.
Oh, these are pretty.
Yeah, so I used the super fancy Todick header pins on it and soldered it up for.
Yep.
I was a little bit worried when Parallax sent over a heart rate monitor to Addie because she's a nurse, and I figured the first thing that would happen when it got here would be that she tried to chase me around the house with it and do experiments on me.
Don't worry.
Oh,
we
dear.
will. I just tested it.
So I believe part of the issue is that this board, they don't actually make this. I think they're just sort of reselling a different
It's
product.
a green board. It's
Okay.
not a Parallax colored board.
Sure.
And also it's usually something that you would integrate in, and it has like surface mount pads on it as well as holes for pins. So I think they just sort of left it that way because if you're going to use it, you're probably going to integrate it into a product.
Sure. So
anyway.
Yeah. So the 3 pins, simple ones, VCC, which can be 3.3 or 5.5 volt, or 5.5, I should say. There's ground, and then there's your signal line, kind of like the ping, kind of like the PIR. So
right.
Yep.
Right.
And so if we go to the code, and again, we're looking at this on learn.parallax.com. It's one of their kickstarts. It's pretty easy. We know our object is PST for Parallax Serial Terminal. We know the con section. We set the pin to be 0. So the signal pin that connects to this polar rate receiver is pin 0.
You can make it whatever you want, but it's configured to pin 0 for this example.
Right. And we got 2 variables, old sample and sample, which both are bytes. And then our program starts the Parallax serial terminal, clears it, sets the signal pin to input.
Right.
And DIR, that's by DIRA with a tilde. Then we write a string to the serial terminal waiting for heartbeat, ... The PST pound NL is new line, right? I prefer doing 13.
Yeah,
but,
well.
Yeah.
This is just sort of a, standard acronym for it. NL, there's CR, there's a bunch of others. 13 is actually CR instead of NL, but.
Oh.
Yeah, so I kind of got that wrong, but.
Okay. All right.
Carriage return and line feed, it's 10 and 13.
Okay.
Yeah.
Those are the ASCII characters for those.
Okay.
Mm-hmm.
And then repeat until the NA pin is...
So what that's actually doing, just so you know, because you probably haven't seen this kind of code before. So when you do in a and a open bracket pin, so it's saying the pin 0, right?
Yeah.
If you just have that as an expression by itself, it will be, if the pin's off, it'll be 0, right? And if the pin's on, it'll be 1. And 1 is true.
Okay.
And 0 is false in this case. And it's basically going repeat until the NA is non-zero.
Okay, so it's 1. So could you also say repeat until NA pin equals 0? I mean equals 1?
Right. You could say equals, you could do that as an expression, or it's a shorthand way of saying the same thing.
Okay, and of course there will be a link to this code in the show description.
Yes.
On the website.
Yes. And then we do PST. So when the pin is turned high, then serial terminal will say heartbeat detected, and then it'll start repeating the main loop where the sample one of the variables will equal the status of the pin, right?
Mm-hmm.
And if sample and old sample.
Okay, so what that's doing is it's using the same trick as the NAHRRX up above.
Okay.
For sample. So it's the same as saying if sample equals 1 and old sample not equal sample, right?
If sample equals 1 and old sample does not. Oh, wow, that's like super shorthand.
Right. So So what they're doing is they're just going, okay, when the thing triggers as being on,
yeah,
and it was off before, because old sample gets assigned to equal sample each time through this loop. So as long as old sample used to be 0 and new sample and sample is on equal to 1, then it will actually go in and print out that it got a beat. Right? And then until it turns off again, it won't print out beat.
Interesting. Okay, I see.
So because now once it's gone through once and the heartbeat has been detected and sample is 1 and old sample was 0 right before it got here, and it prints out the beat, immediately after that it's going to say old sample equals sample, which is going to make it equal to the 1. And then the next time around, if it's still on, which the signal will still be on if it's looping around quickly enough, it won't print beat again because it only does that when old sample is not equal to sample from the previous time. So it's a way to cause it to only do the leading edge detection.
Okay.
So whenever it goes from off to on, it'll print beat. But then it waits for it to go back off again and then come back from off to on to print out beat again.
I see. Is there a simpler way to say that?
This is sort of a more straightforward, simple spin code way of doing it. You could set up some, edge detected clock mode and use that to track it. Or you might be able to use like the weight PNE and weight PEQ values on that bit to wait
sounds
for
like a better idea to me.
So wait.
Right.
So wait.
Wait
until pin.
Wait till it turns on.
Yeah.
And then print out beat, and then in the if wait till it turns off.
And with a parallax propeller, because you've got 8 cogs going, you can just dedicate a single cog to use those blocking commands that wait. It just locks it until the state happens, and then it does something.
Right, but for this particular example, you don't even need to run in another cog because it's literally just waiting in this loop anyway. It's not trying to do anything else other than print that a heartbeat occurred.
Well, I'm assuming that this is rolled into some sort of a project.
Well, yeah. If you had it in a project, you could then set it off in another cog and, count beats or set up when a beat has occurred to set a variable or something. Yeah.
So you'd wait until the pin equaled 1, and then you'd wait until the pin equaled off, like 0, and then print beat.
No, so you'd wait for it to be. So you'd start off waiting for it to be off, right?
Yeah.
And then you'd go from there. You'd enter your loop, and then you'd wait for it to turn on. And as soon as it turned on, you'd print beat.
Okay.
And then wait for it before doing anything else. You'd wait for it to turn off. And then you would loop back around and wait for it to turn on again.
Okay.
So you'd use the weight PNE and weight PEQ.
I think I might like that better.
Yeah. Perfect use for those commands.
I don't know, but I think. Anyway,
yeah.
So...
The nice thing about those is they also put the propeller into a lower power state.
Okay.
So it would use less power. So if you had it hooked up to a battery or something, it would conserve battery usage more.
Sure. So when you look at this in the serial terminal, you'll see, waiting for the heartbeat detected, and then every single time there's a beat, you'll see the word beat printed onto the serial terminal. So beat, beat,
yep.
beat, beat.
Assuming you have a standard heartbeat.
Yeah.
And then when your heart starts to stop because you're having a heart attack, it's like drop the bass line, beat, beat.
Yeah, doubtful. It's called call 911. Beat, 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 beat.
Right.
So then my question is would it be easy enough to use this to get your heart rate? Obviously I could put up a clock, I could count how many beats I see in the course of 60 seconds, but is there a way to do it in code?
Well, you could have the code keep track of how much time has elapsed using the clock counter.
Microcontrollers are really good at keeping time.
Okay.
Right. The other thing you could set up is the actual counter stuff that we talked about in the past. It's a little more complicated, but you could set it up to count every time the leading edge occurred, and then just every 60 seconds or every X number of seconds, read how many beats were registered out of the counter registers, and then do your math to figure out what their heart rate is. Like, if you don't want to wait the full 60 seconds, you could just do like 5 seconds worth and then multiply it by 20, or however many, 30,
right.
6, whatever.
Okay.
You know what I mean?
Yep, I do. I completely do. So it's kind of cool. It is pretty simple, and it's really not that much rocket science in order to get it working and to see it actually working. So that's the polar heart rate receiver.
Yeah, the receiver makes it really easy because it's just setting the signal pin high and low based on receiving the signal from the heart rate monitor.
Yeah, and we know some of you guys are working on various challenges for medical equipment, so there's that. Now, we had a comment, was it on last week's episode?
I think so.
From Serial LCD.
Yeah, from BrainStrain.
Okay.
Yep. And is it okay if I read the whole thing?
Mm-hmm.
Okay. Thank you for producing your show. I'm a newbie, and I very much appreciate it. Woohoo! I'm presently trying to read the output from the 2-axis joystick through an LTC 1298 analog to digital converter. I need to read and process the output to do what joysticks do, point at directions. My XY range test results somewhat matched yours, by the way. It would be very cool if you followed up your joystick show with a second one. Then you could help people read the XY input from the joystick and use that info to light up one of 4 LEDs to show 4 basic directions at the 90-degree intervals for up, down, left, and right. Thanks.
Okay, so yeah, that's more of like a video that we would do for our Tymkrs TV show on YouTube. So maybe Addie will do that. Yeah, that'd be cool.
I think,
And why the ADC rather than the RC time, I wonder?
Maybe he just wants to use that to get, different, potentially more accurate results without having to consume timing circuitry. It just depends. He didn't specify here. He may not actually be using a propeller, so he might be using some other processor.
Sure.
That might not be able to do
assuming an
RC
ADC here, basically what you're going to want to do is look at the voltage coming in on the two through the 2 potentiometers that are in the joystick, and the voltage is going to range from.
It's going to depend.
It's going to be a little bit
setup.
different for each one and how you're hooking it up, but it's going to be a range from one upper value to a lower value for each one of the potentiometers.
Right.
And you're going to be wanting to create some sort of thresholding on that information so that it only triggers as being pushed up. If it's, I don't know if it would be higher or lower side of the voltage, depends on how you wired it.
Right. Yeah.
And same for left or right.
Yeah, it's one of these things where when you're dealing with an analog stick and you're actually physically placing it, you want to set up the circuit and just read the raw values and then move the stick into each position and note all the values so that you can do the appropriate thresholds in the appropriate directions. And it's going to be different depending on how you set up your joystick, which orientation you put it in, and which inputs go to which channel of your ADC and whatnot.
Yeah, it's important to note that there's a lot of different ways to wire these up.
Right. And so,
but once you have it wired up and got it reading values, you can just write a little simple program that dumps out the raw values and move the stick in all the different directions that you care about and note the values, and then you can create thresholds to go, okay, If I move the stick to the left, the first channel goes down towards 0 volts, right? So you can note that, and then if it gets less than, an ADC reading of say 100 or maybe 15, depends on the range, but you have some less than value, then that they push to the right.
So let me explain this in Addie style.
I think we pretty much covered it already.
Yeah, but you guys are like, whoa, craziness to like a new.
we got stuff we need to get to here.
I know, I got it. Let me explain. So say left and right is 0 to 10, right? 0 being left, 10 being right. What you can say is, okay, the center is at 5. So if X is greater than or equal to 0 and less than or equal to 5, then the left LED lights up. Or if X is greater than or equal to, I guess, 5. Well, figure out 5, okay? I mean,
you usually say greater than, not equal to, because the center, you don't want it to display when it's on the center.
I guess so, okay.
You want to create yourself a dead zone in the middle.
So if greater than 5 and less than or equal to 10, then the right LED would light up. And I think that would go for the same for top and bottom, for up and down. So like with our values that we got on the serial terminal, that's all you have to do. Just see where your center is, see where your leftmost, rightmost, topmost, bottommost, and then.
But you can't just divide it in half like that. You need to have a spot in the middle where it reads as not being pressed in either direction.
Right. So you might
have to divide it into 3.
Right. So you might say greater than 7 to go one way and less than 4 or 3 to go the other way. And then between 3 and 7 will be your dead zone in the middle.
Right.
All right. So thank you for that question. If you need any more questions or need any more answers on that, like if we need to explain something else, let us know. Mm-hmm. And anyone else out there that has any questions too, we're not just here to help Addie. We're happy to help other people too. Honestly, it gets kind of tiring helping her. She's such a pain. Yeah. All right. Now, other than being a pain, she's also extremely productive, and I would like it if Addie would explain the new series that she's starting over on our YouTube channel.
Yes. So, as you know, like on First Spin, we've been going through all of these different modules. We've been going through the code, through the hardware, all of that wonderful, wonderful stuff. But I don't think there's actually any examples of how to make these modules wireless. So we had some XPs that we got to play with, and I decided why not provide the hardware as well as the code for making these different modules wireless. So I took quite a bit of time over the last few weeks to look at these modules and write the code up and test them. So if you pay attention to the Tumblr as well as to the YouTube, I think last week we did.
You can find links to this stuff at tymkrs.com.
Or look up Toymaker Television.
Firstspin.tv is a production of tymkrs.com. We do a lot of other shows too. And if you like this one, you should check out the other ones because there's a lot of related and extended information on the stuff we talk about here over on those channels.
Right. And so let me just let you guys know real quick what the modules that I've written up. The ping sensor, 2-axis joystick, PIR sensor, 5-position switch. We have, let's see, there's 5 more in the queue. There's the compass module, there's the altimeter module, the GPS module, the gyroscope module, and that's it. Yeah, so 4. So 4 on top of what? 4? That's 8. So 8 modules altogether, which I think is awesome.
So she's got wiring, diagrams, source code examples.
Yep.
And soon to be video examples of all of these modules actually being used in a wireless context.
Correct. So if you have any questions, just let me know. And it's pretty much a basic, like you turn on your microcontrollers and it works wirelessly to a serial terminal. Yeah. So we'll see how it evolves from there. And if you guys have any suggestions for me, let me know.
All right. That's all the time we have for this week. You can find this show every Tuesday evening at firstspin.tv. There's an RSS feed on the show too. So if you want to have it automatically download to your phone or music player, you can do that there too. That's it for us for this week. We'll see you guys next week.
Bye.
Bye.
See ya.